Om Swastiastu. Let me introduce myself. My name is Arthur Steve Pamolango. I'm the student of Udayana University from the Mechanical Engineering programs, and today I wanna present to you that my metallurgy course assignment that name Modern Alloy Production. The book source that I use is Metallurgy for the Non-Metallurgy second edition. The first is effect of alloying on solidification. The solidification of alloy is more complex than of the pure metals because the different elements in the alloy process different melting temperatures. Pure metals freeze and melt at the specific temperatures. Alloys freeze and melt over the temperature range. The result is so-called Mesin zone for alloy solidification under equilibrium condition. The Mesin zone represents the temperature extreme between which to pass solid or liquid composition in percent. Different alloy composition have different liquidus and solidus temperature, and the line that appears on the binary phase diagram that differentiate these regions from each other are referred to liquidus line and solidus line respectively. When some of the liquid metal begins to solidify or at this liquidus, the technical term for this event is freezing. Freezing continues until solidification is complete or at the solidus. Second is solidification structure. During the early stage of solidification, the microstructure of cast alloy can be altered from a dendritic structure toward a reset or practical morphology. Forced convection, current, or mechanical agitation occurs here and turbulence in the liquid, which promotes the solidification of the globular semi-solid structure. However, recent research and development shows that it's not necessary to use shear force to produce the globular semi-solid structure. Instead, a slurry with an ideal semi-solid structure can be produced directly from the melt if the temperature of the melt is such that many nuclei or copious nucleation are generated, and if the nuclei do not grow past the certain point or suppression of dendritic growth or melt back into the bulk liquid. This controlled nucleation and growth concept is the genesis of various processes and methodologies to generate semi-solid slurries from the liquid state. Next is melting furnace. Electric arc furnace, one of the furnace most commonly used to melt steel alloys, is electric arc furnace or EAF. A typical EAF is refractory line vessel with a bowl-shaped heart that is covered with a retractable hemispherical roof. Induction furnace. Induction furnace have become a widely used means for melting ferrous alloy and increasingly non-ferrous alloy as well. A wide range of metal can be melted with this type of furnace, although little refining of the metal is possible. And the last one is crackable furnace. The crackable furnace of antiquity were in the form of well-fired clay pots and gave early metalwork the ability to melt metal in durable container that could then be used to pour molten materials into a mold. Molten metal processing. Molten metal are processed and handled in the various ways depending on the alloy and melting practice that are used. Melting is a basic way of combining elements for the purpose of alloying, and overall chemical composition of the molten alloy must be carefully controlled and processed before casting can take place. The reactivity of molten metal at high temperature also requires special processing techniques for removing or preventing the formation of inclusion, impurities, or dissolved gases in the melt. Fluxing of molten metals is often the first step in obtaining a clean melt. Fluxing is a term commonly used in foundries and melting department that refers to molten metals treatment and addition of reactive chemical compounds or inert gases. Primary production casting. Static ingot casting. Several ingot casting processes have been designed and developed from downstream manufacturing process. The most common static ingot casting, where molten metal is poured into a vertical opened mold. The mold is made of metal, usually cast iron, and is tempered along its length, so the solidified metal can be easily withdrawn from it. Continuous casting process. Continuous casting may be defined as the continuous solidification and withdrawal of product from an opened shaping mold. Today, continuous casting is a common production method for steel, copper alloy, and aluminum alloys. The quality of continuously cast metal can, in certain respects, be superior to that of the statically cast ingot. Foundry casting. Casting with expandable molds. Casting with expandable molds provides the tremendous freedom of design in terms of size, shape, and product quality. Expandable mold methods are classified further as expandable molds with permanent patterns and expandable molds with expandable patterns. Permanent mold casting. Permanent mold casting is particularly suitable for the height of volume production of casting with a very uniform wall thickness and limited undercuts or intricate internal coring. The process can also be used to produce complex casting. Die casting. Die casting is generally limited to metals with low melting points. However, high-pressure die casting is one of the fastest methods for net-shaped manufacturing of parts from non-ferrous alloys. Non-ferrous alloy casting. Aluminum casting alloys are most versatile of all common foundry alloy and generally have the highest castability rating. As casting materials, aluminum alloys have this favorable characteristic. Good fluidity for filling thin section, low liquidus temperature relative to those required for many other metals, rapid heat transfer from the molten aluminum to the mold, providing shorter casting cycles. Hydrogen is the only gas with appreciable solubility in aluminum and its alloy, and hydrogen solubility in aluminum can be readily controlled by processing methods. Many aluminum alloys are relatively free from hot source cracking and tearing tendencies. Chemical stability, and the last one is good as cast surface finish with lustrous surface that suffer few or no blemishes. Non-ferrous casting alloys. Copper casting alloys. Copper casting alloys are available as sand, continuous, centrifugal, permanent mold, and some die casting. They are generally similar to their rough counterparts but have their own unique composition and property characteristics. Magnesium casting alloys. Magnesium casting of all types has found use in many commercial applications, especially where their lightness and rigidity are a major advantage, such as for chainsaw bodies, computer components, camera bodies, and certain portable tools and equipment. The last one is zinc casting alloys. Die casting is the process most often used for shaping zinc alloys. Sand casting, permanent mold casting, and continuous casting of zinc alloy are most practiced, but account for less than 10% of zinc casting tonnage. And the last one is powder metallurgy. One of the more recent metallurgy development in the manufacture of modern alloy is the development of powder metallurgy processing. Metal powders can be produced using a wide variety of mechanical methods as well as by chemical and electrochemical methods. Atomizing is the dominant method for producing metals and pre-alloyed powders from aluminum, brass, iron, low alloy steels, stainless steels, tool steels, super alloys, titanium alloys, and many other important industry alloys. That's all of my presentation today, and thank you very much.